In this video, we are going to be discussing the structural aspects of the ELF method. So remember, there's two general sets of aspects. One is the site information, the other is the structural information. So here we're going to talk about the structural information. So what do we do in regards to the structure itself? Well, we first obtain the structural response modification coefficient, and we call that R, okay? And we obtain this from table 12.2-1 of ASCE 716. So this is a big table. It's in the provisions. It's a big table. And depending on the type of structural system you have, you're going to have a different R value. So you have to enter that table and pull out this number R, okay? The next thing you do is you're going to compute the fundamental period, which is called T sub A, of the structure, okay? And so you're going to reference section 12.8.2.1 of ASCE 716, okay? Now, notice there's a few different versions of this formula. The most popular one we're typically going to use, so we're going to say typically we're going to use T sub A equals C sub T H sub N raised to the X power, okay? Now, again, there's some different formulations for T sub A, but this is the most common one we're going to use, okay? But read through ASCE 7 and the textbook so you're kind of familiar with it, okay? Next thing you're going to do is determine the long period, which we call T sub L, from figures 22-14 and on of ASCE 716, okay? This is an upper limit of T sub A, okay? So you basically, you calculate this T sub A value and you cannot exceed the long period, okay? And then finally what we do is we compute the seismic response coefficient, C sub S, which is computed as C sub S equals SDS. Now, what's SDS? That's our design spectral acceleration that we discussed earlier in the previous video. And then we say divided by R over I sub E, okay? Where I sub E is our earthquake importance factor. And we've explored this before. This comes from table 1.5-2 of ASCE 7. This is also in the textbook. I think I asked you a homework question to pull the importance factor out of one of these tables for specifically for earthquake purposes. So this is something you have seen before a little bit, okay? Now we must compute an upper and lower limit of C sub S, okay? So if you're taking a look at the textbook, there's upper and lower limit stipulations on page 117 of the text. Okay, so we're going to say see page 117 of text. So read this carefully, okay? Read this carefully. You have an upper limit and a lower limit, but there's two ways to calculate the upper limit and two ways to calculate the lower limit, and you have to abide by these four statements that are dictated in the textbook and in ASCE 7. But in general, you have C sub S lower limit, clean that up, C sub S lower limit, and then your C sub S value that you calculate should be in between the lower limit and the upper limit. Okay, so let me ask you a question. What happens if you calculate a C sub S value and it's bigger than the upper limit? Well, you use the upper limit as C sub S. What happens if you calculate a C sub S value and it's smaller than the lower limit? Well, then you use the lower limit for C sub S. So what your calculated value of C sub S should be in between this upper and lower limit. But if it's not, that's when you use the upper and lower limit instead of C sub S. Okay? Upper or lower limit instead of C sub S. Okay? And then the next thing we do, we're almost done. We're going to compute the base shear force. And if you remember, this is going to be V. And we say V is equal to C sub S times W. Well, you know what W is. W is going to be the total dead load of the structure. So W equals the summation of those little W sub I as I goes from 1 to N, okay? What's W sub I? Well, if you go back to the previous video, those were your lump weights or your lump masses at each story, okay? Those are dead loads, okay? Then what we can do is compute each story force, okay? So for story X, we have F sub X equals CVX times that base shear, you know, the base shear that we just calculated. Make my V look a little better. Base shear that we just calculated. And then CVX equals W sub X H sub X raised to the K power divided by the summation as I goes from 1 to N, W sub I H sub I raised to the K power. Okay? W sub X is the dead load for story X. H sub X is height from ground to story X. And then what we can do is I'm going to refer you to page 118 of the text. I'm going to say for the K, that K value, I'm going to say C page 118 of text. Also on page 118, I have a general summary. So you need to be reading this. I know this is kind of a long-winded procedure, but you need to be reading through this because the next thing we're going to cover is an example, and I'm going to expect you to be familiar with these steps and this 9-step procedure on page 118 before we tackle this next example.